So in this next angles lesson, we're going to look at some special triangles. So first of all, we're going to look at a triangle where we've got two equal sides. Hopefully you know that the name for a triangle with two equal sides is an isosceles triangle. So as well as having the two equal sides, which is these little dashes, right, would indicate there are also two equal angles. So when we're doing angles, we would be looking for you to use the information that would indicate. So the sides, or the angles rather, across from the equal sides would be the ones where we would have the equal angles. So if we mark in there with little dots to indicate that those are our equal angles across from the sides. So again, just on this diagram here, that does not mean that the two equal angles at the bottom, if we say, so this one here would indicate one equal angle, and this angle up here would be where our other equal angle would be. So put two little dots there and there. So don't always assume that the equal angles are going to be at the bottom, but what you should know is the equal angles in an isosceles triangle, where you've got these wee dashes to indicate they're your equal sides, your equal angles are across from both of your sides. So like say that means here and here, so then you've got one different angle inside the triangle. So this would be the one that was different. So we'll be using that property about the equal angles to do some calculations. Before we do that, there's another type of triangle that we should be aware of, and that is one where we've got all three sides are equal, and therefore actually all three angles are equal. So they're all the same. And what we want to know is what is that type of triangle called? And if we know that everything about that triangle is equal, then we can remember it's called an equilateral triangle. And because all the angles are equal, it lets us say that actually what we can work out is the size of those angles. And because we know angles on a triangle add up to 180, if you divide 180 by 3, you'll get 60, and that tells you what size all the angles inside an equilateral triangle are all 60 degrees. So if you make a little note for yourself that each angle inside the triangle is 60 degrees in an equilateral triangle. So let's look at some calculations. So first of all, this one here, calculate the missing angles. You can clearly see we've only got one angle in this triangle, but we do have these wee dashes which would indicate that it's an isosceles triangle. So two equal sides, and remember, right, that does mean that we've therefore got two equal angles, and our equal angles, remember, are across from the equal sides. So in this particular triangle, that would allow me to say, well, actually the ones that are equal will be the A and the 57. So that lets me write down that angle A needs to be 57 because that's the equal ones. And if I then add up my two angles of 57 and 57, so I then have 114 degrees, and if I then take that away from 180, I then have your angle, the other one that you've still to get would be angle B, and that would be 66 degrees. So we're able to work out, even though we only had one angle, we could still work out the other two, but that's because it's an isosceles triangle. So here's a second example. So again, it's an isosceles triangle, and again, for what we should be looking at with this one is, here's your equal side. That means that angle there and this is your equal side, so that one there. So what we know, if we were to write down, what do we know? We know that angle C must be equal to D. That's my equal pairs. So how am I going to get that if I know that I've only got one angle at the moment? Well, if I do 180, take away the angle that I know, which is 56, I then know that your angle we're looking for here must be the 124 is shared equally between angle C and D. So if I do 2 into 124, which is going to give me 62, that would tell me that angle C needs to be 62 and angle D is also equal to 62 degrees. So using that property about isosceles triangles, it can be quite important here to draw your diagram for yourself and think through which ones are equal, which angles are equal. So in this third diagram, got a wee bit more detail in it as well, and back to a slightly more complicated diagram. We recognise it's an isosceles triangle, so if you've sketched the diagram, then marking on where the equal angles are, and that, remember, will be across from your equal sides. So that would tell us in this particular diagram that A and B are our equal angles. However, inside that triangle, I don't know any of the angles at all, so I'm unable to do any instant calculation right away. But what I can notice is that the one other piece of information that we've got is that this angle 110 degrees is fitted together beside angle A, and they're making a straight angle. So that would tell you that if you do 180, take away 110, which is of course 70, that would tell you that angle A is 70. Now, because we've already looked at the fact we've got isosceles triangle up here and we know that angle A and B are equal, we can also write down that means we've got 70 there as well. So now what I've got is inside my, when I look at my triangle now, I've now got two angles of 70 degrees, and if I add them together, I get 140, and if I then take that away from 180, I will work out that angle C therefore needs to be equal to 40. So that's using your angle property of straight angle and your sum of angles in a triangle, but also recognising your equal angles in isosceles triangles. So it's about bringing all the facts together and trying to use them in combination. So drawing a diagram will be important for these more detailed calculations that you need to do.